Hello and welcome. In this session, we're going to talk about what is sustainable software development and why we believe that the future software must be green. I am Meelis from Helmes. I'm currently leading the organizational development and innovation. And I've been in Helmes for 20 years and in software development industry for 30 years. In multiple different roles, so I've seen how complex software systems have been built from inside and outside. And as an ex-engineer, I really care about software efficiency. And also, since I'm a father of two, I care what will happen in the future and how does our work in software development industry impact the world and the environment around us. So I have a few slides here. Can I see the slides, please? Yep. So the main point here is that digital is not sustainable by default. And let's look into this, let's say, misconception. Many of the IT leaders and also business leaders believe that when part of your business has been digitalized or automated, that it doesn't have any carbon footprint, or it has a small footprint, or it's negligible. Some believe it is optimized by default, and this is not true. The thing with nowadays technology is it is so easy and rather cheap to buy new technology. It is easy and simple to scale up the technology using cloud and do it with a few simple mouse clicks. But everything leaves a footprint. So let's look into this. The report from last year has calculated that our ICT industry emissions are up to 5% of the global CO2 footprint. Can you imagine this number? While 5% doesn't feel big, everybody is worried about aviation and what is the environmental harm in this. Everybody's worried about global road transportation. And looking at this number, the ICT emissions are actually higher than global aviation and equal to global road transport. So this really should make us concerned about what can we do. When we look to the future, it has been estimated that by the end of this decade, the ICT will use 13% of the world's electricity. I personally believe that based on the last year's changes and the progression of the technology around us, the number will be higher if we don't take action. What is also worrisome is that the ICT industry is growing much faster than all the other industries. And this means also larger energy consumption. So when we look at where this ICT carbon footprint comes from, what are the components, then many leaders believe that you all heard about the cloud and data centers and believe that major footprint comes from these. But in reality, there are multiple more components. And what came as a surprise for me when we looked into these reports a few years ago is that actually our end user devices, the mobile phones, the laptops, the tablets, these are the ones where the majority of the carbon footprint comes from. And even though the hardware and manufacturing the hardware and transporting and dispose is the majority of all of this, there is one uniting component for all of these components, and that is software. Software will determine the amount of waste, the amount of energy consumption that can be happening that is actually harming our environment. So what I'm trying to say is, as other industries, the ICT industry also needs a green transformation. There's another misconception as well. When you understand that there is a footprint in anything that we do, many leaders believe that building green software is expensive. They believe that it will increase infrastructure costs. Some believe that it will overcomplify the systems, so complexity challenges. And some even believe that the performance of these products and systems will lower. These aspects are also incorrect. As an ex-engineer, and maybe some of you are as well, we know that optimization brings increases in performance. Optimization brings decreases for hardware. And of course, it takes some architectural thinking and decision making to avoid increasing complexity. But let's look into a study that Accenture has done. So Accenture is one of the biggest IT companies in the world. And what they found is that organizations who are able to align their business, technology, and sustainability goals can actually achieve better business results. So what this means is when you are more effective as an organization, it helps the business growth. When instead of having abundant resources, you are constrained, and creativity loves constraints, you get innovation. And we already see this innovation. It's really magical what good, positive constraints can do. When you're building more efficient systems, the cost savings can be dramatically big on energy and on the resources as well. Organizations who actually care about the future, care about the planet, care about the environment. I don't know any human being who doesn't care about the world we live in. So this helps to attract top talent. And it kind of makes sense to care and show that you care with not only words, but through the actions. And when talking about the ESG, then anything you do to lessen the harm on the environment shows on the positive kind of ESG metrics. So in brief, luckily, sustainable software, if done right, will be faster and will cost less. And when I say cost less, we have to think about the total cost of ownership of the software. It's not about the first year. The larger your business becomes, the more it kind of grows, the more impact you will get from these cost reductions. So sustainable software is not so much about doing extra, but doing the right things and doing them right. If we now look at different ways of the organization, how can they approach becoming green digital? First of all, we have to solve the right problem. Automating and digitizing parts of the business processes is normal. Every company does it. And while we know that these unautomated, non-digital systems have the largest part of unoptimized and the largest emissions, digitizing by default doesn't ensure that we are still not causing environmental harm. Because it's very easy to put more money and put more resources and hardware into these digital solutions and still create large emissions, especially when you are scaling up and your organization is growing. So while building new systems, it kind of makes sense to adopt the green mindset and straight start to design a green digital system. But working with existing organizational kind of systems and applications, the ones that are legacy and the ones that you are in the building, in the development currently, it kind of makes sense to have different approaches. So here I'm going to share a few strategical levers and go-to solutions that we can do. So moving from from the existing to the green digital. First of all, most organization, the larger you are, the older company you are, there are many, many applications lying around. Some of them are legacy, some you just keeping up, they are spending energy and not creating much value. We can retire them. We can consolidate these small things, put them into a cloud in a smaller space or to the dedicated hosting. We can find out from this legacy system some of the components that are really energy inefficient and replace only these parts, and it is good enough to continue for some years. So the main recommendation is to look at how to move into cloud, because cloud provides us more options to build more sustainable solutions. Without cloud, it is more, let's say, it is more difficult and expensive. But cloud by default isn't sustainable as well. And it requires a separate skill to optimize the cloud. And of course, for this, we need skills and knowledge and experience. And the fourth point that I want to mention, something that we in Helmes especially look into, is how in the software development we can apply this green mindset to agile and lean development. So agile and lean, the go-to principles, frameworks, methodologies that every professional and a great software team uses. Agile is about creating value as quickly as possible. Through iteration, you create something, you test it, okay, use it, what works, change, iterate, and continue. Lean is about creating value, but understanding how to do it with fewer resources. And it's about eliminating waste. Now, when we adopt the green mindset, and green is about minimizing environmental harm, we get down to three main principles and three main activities that we need to do. First of them is how to build energy efficient systems. And in lay person terms, it means how to build a system that takes less electricity. It's as simple as that. Usually it's done through optimization. The second aspect is how to make sure that it is hardware efficient. So while we can make efficient system but still kind of use extra hardware, it doesn't make sense. So how to ensure that we need even less physical resources? That might be a little bit about smart green architecture. And third point is, since there are a lot of dirty energy around the world, how to build systems that are energy intelligent. So how to use cleaner energy, how to build a kind of an intelligence inside of the system that when they are doing a lot of computation and processing that consumes a lot of power, that they know they will prefer to use cleaner energy. They run maybe during night, maybe they are running in a distributed mode that consumes less energy or cleaner energy. All of these aspects can be implemented into the software if we use the green mindset and can have dramatic effect. Talking about dramatic effect, and now I love this. This is the power of sustainable software. In some of our business application projects, due to some crazy engineers who just love to build efficient systems. We have seen it is possible to reduce these critical components energy consumption up to 100 times. And with data, it is even possible to reduce, in some cases, the data waste up to 1,000 times. So it is really powerful if we have the skills and we have the mindset. Now what Helmes has done, how we think about software development, since our product is building world-class teams, and these teams are building products for the leading companies. It's only not about the coding. So when we look at the software development, often regarding sustainability, everybody talks about green coding. Green coding is just one component. A strategic approach is to understand who is actually needing the software, who is ordering the software, who are the business people that kind of want to build it. So the business leaders, the team leaders, the architects, the designers and analysts, operations people, they all need to collaborate. So smart collaboration with the green principles. So let's look at how each role can contribute. So in Helmes, last year, we created a work group, a community of sustainability enthusiasts in each of these areas. And we put them together in the room, and they all created checklists about green mindset activities to check what can we do as a business leader to kind of empower this green mindset and sustainable green software. As a business leader, it's about creating the culture, the green culture, explaining the value of this to the clients, explaining the numbers, what's happening in our environment, talking with the partners and the subcontractors. When you talk about the team leader needs to ensure that when they are building the team, that the people have the green skills and agree a way of working between all the stakeholders. It's all about the collaboration, and it doesn't come naturally, not yet at least. When we talk about the analysts and designers who work with the business side and with the users, they need to know what kind of questions to ask, that we understand the potential impact of this business process when it's designed one way or another way, and how to influence the mindset of our partners and other business people to make the greener decisions. Also, the analyst is one of the most important roads here to discover the danger zones and the opportunities as well. We have the architects, both of the software architects and infrastructure architects, who now, they know all the technologies, but up until now, many of them have not considered the energy consumption impact and the harm it can do. It's technology, it works. All of these technologies work. All of these can be used to create your systems and applications. But they need to understand which ones are more efficient. So it's about green tech alternatives and green architectural decisions. When we talk about, and now we come into the coding part, the part that everybody talks about, green coding. In here, the tech lead, the principal engineer or the lead engineer with the developers and the testers, they have to understand that, yes, we have created some green guidelines, but we have to implement these practices. We have to follow them up. Otherwise, it's just talk. So all these green software patterns need to be actually implemented. And now, at the end of the line, there's the operations and DevOps. Usually, they ensure that the systems are running. When they don't have enough storage space, give them more space. They are running out of some other capacity about the computing, give them more servers. But now, they should also look about how can we optimize and reduce the power consumption and the digital waste. So I would say every ethical, really senior professional engineer is already doing this. But they're doing it locally, like works on my computer. We have to do it strategically, working together. So smart collaboration is something that in Helmes we put the most effort into. And what we also did, just as an example, we have real checklists, real recommendations and activities that the junior people can learn from. They can understand that there are different options how to build greener software for each of these roles. What I'm really happy about is we are not alone. The world cares. There are communities of building more sustainable green software and new evolving standards. So not every company needs to go and create a work group and build these patterns and design these principles. There are already guidelines how to build sustainable web design. There are already well-written and described software patterns. There are also designed a formula how to calculate the software carbon intensity. While some of these activities are not the easiest to do, this is something that every professional needs to learn how to do. And it will be a normality that software or parts of the software will become benchmarked. In the same way that our fridges are like, it's efficient or less efficiency, like A, B, C, D grades, our software will also in the future be rated. So these are evolving standards, and then I put some links down there that everybody can check out. So building green software is not so much doing extra, but doing it right. It means that when you do it in a professional and correct way, then it will also be green. And now I'd like to introduce my good colleague, Kaspar Kinsiver. While I am mentioning about the principles and the frameworks, he's actually living the life and living the green mindset for already 10 years. So please, Kaspar, help us to explain how everybody can do this in their own teams.
Thank you, Melis. Hello from my side as well. I'm Kaspar Kinsiver. I'm a team lead at Helmes. And I would say I'm a sustainable software enthusiast. I'm in IT for 15 years, and last 10 years I've been with Helmes, where we have built good quality systems that are efficient and sustainable. So if we talk about sustainable software, what is the goal of it? The goal of sustainable software solution is to limit the impact the system has on the planet around us. And this is on multiple levels. It's on the software itself when it's running. It's the architecture that this software solution is using and the infrastructure that this software is running on. And all these play like a big role in the whole emission or the impact that that system has on the world. So when we take a look at the ICT emission as total, there are wide range of things around software itself that play a part. It's networks, it's IT services, end user devices, data centers. But how this actually impacts software and how software impacts these different categories. Let's take a more practical view on that. If we take a look at around the software, then software itself can impact a lot of different areas and impact the emission or the impact these components each have and how much emissions come from that. Let's take the first one on the left, and hardware. Depending on how we build our software, it is highly dependent on how often we have to replace our hardware, how much we have to build it or buy it, and also how long we can use it. The second part is data centers, directly depending on how wasteful or how efficient our solution is. In total, the number of data centers around the world and how big they are depends on that. And building a single data center is huge emission. The less data centers we can build to run the same amount of software, the better it is. The next one is network. Network is somewhat invisible to us all. We don't know it's there. We know it's there, but we don't see it. We know that we have 3G around us. We know that there are some cables, some network places where data goes back and forth, but we don't really see it that well. But the energy and resources going to run these networks is impacted directly by the software we are building and how we are building it. The next one is data, and data relates directly to network as well, because data is moving in networks back and forth. The amount of data our system uses, produces, and stores is dependent highly on how our solution is designed, what are our policies on that, and how we manage the life cycle of data. And this impacts the emissions and then impact that our solution has on the planet around us. If data, network, and data centers are all physical, then if we talk about sustainable software, there are many pieces of the puzzle that are not that visible, not that physical. And one of those is user behavior and how our users are using the software that we are building, and where they are using it, and how they are using it on these devices. Software, well-built software, can direct user to work on the software in a way that's less impactful or less wasteful. And also the users impact the software as well. And software has to be ready for that if the users do something not so great for our planet. And this is something that impacts the software and how much resources this software uses quite a bit, but we are getting to this in a bit. So with all this, we have come up with 3 pillars of sustainable software, 3 pillars of key points or key areas that we see impact the software and how software impacts the world. The first one of those is keeping it simple. The second one is data and how to control your data and keep it under your control. And the third pillar is where and how to run your solution. Let's take a closer look at those. Keep it simple. Sounds simple. If we talk about sustainable software, then this process of creating sustainable solution starts long before we get into any technical details, before we get into architects or developers or operations people. It comes and starts from the business level. The more simplified we get in our business, and then the less, if our business processes are less complicated, less complex, then we need less resources to solve these issues and solve these business processes. We don't need that many computers, that many servers to get the exact same value. So the first step is to lean your business processes, doing things more efficiently on people level, not on the technical level, but people level. If your business processes are already optimized and you see that there's no way to go better on that, and we start developing it, then the golden rule of sustainable software is that well-built solution is already sustainable. If the system we are building is built well, efficiently, it has good data structure and database design, then this can be already considered as sustainable software. The next step is redesigning the system when the requirements change. Everybody are often eager about building new solutions. We have a great plan, we build something, it gets ready, users start using it, and then it stays like that. What we don't see that often is that the customers come to us that our requirements went away, what we can do about the system. Can we make it simpler? Can we make it more efficient? This is something that is crucial part of sustainable software development. Not only changing your system or redesigning it when your system gets more complex, because that happens often. We get the requirements and we have to change the system. But we should do the same thing when system gets, or the business process gets simpler. Because yes, the more complex system, technical-wise, more complex system can handle the less complex business process without any issues. But it cannot make it in an efficient way, because running a more complex system, even though the business process is simpler, takes energy. Just running the system, keeping it idling, is taking energy as well, and therefore redesigning system when the business processes change makes sense, and it makes the system more sustainable. Going further with that point of changing already existing system is keeping it maintained well, and also develop further regarding technical updates. We often see that systems get built and then it stays like that for the rest of the life cycle of the system. Yes, there will be some minor updates, but no new solutions, no new technologies. From sustainability point of view, this is not optimal, because usually software solutions are built using third-party components. And all these components, either it's programming language, some framework, or a specific functionality that we have borrowed from some other third-party developer, all these developed in time, and they get more efficient. And if we keep our system well maintained, our system gets all this efficiency into itself as well. The next step in keeping it simple is refactoring your system. We talked about maintaining the system, but as important is actually refactoring the system and using new ways of doing things. For example, if we talk about Google Cloud or Amazon AWS or Microsoft Azure cloud environments and platforms, they are developing their services constantly. After every other day or week, new services pop up, and maybe these services are better for our business case, for our solution, depending on how they can configure, how they can be run, etc. Being on the picture, getting to know the new solutions and applying where it makes sense, applying these services, new ways of doing things to our solution can make things more sustainable. A real-life example is our own customer who replaced one cloud service with another, and all we got is chance to configure the service a bit differently based on our needs, and our cost on running this service dropped 30%. 30% cost reduction in cloud to run this service by simply applying another service, a new service, more optimized service for our business case. And if we talk about cost, then it doesn't sound like sustainable software, what sustainability has to do with cost. But if we talk about solutions like cloud platforms, we see that cost has direct correlation to efficiency. If the cost drops, the system is more efficient. And more efficient system means also that it's less impactful on the planet. Next point on keeping it simple is avoiding to use third-party components that don't make sense. Often, if developers start building something, what they get is, I have this pre-built component that somebody else has already done, it's developed, I can use it. And it often works, and works well. But what is the case in such scenarios as well, is that these components do a lot of things, and we usually don't need all these things. We probably need 1 or 2 functionalities from this third-party component. But it often happens that these components have to be run in our system to use this 1 or 2 functionalities, but it's easier to build. But what is the end result is that if we run this to get this one functionality, we get the functionality, but we are running this huge, in some cases it's huge, third-party component that we actually don't need. And this is wasteful and it's not sustainable at all. So keeping it simple begins with business and processes, but it also means the maintenance, refactoring, and using components that make sense. Because if you do it like in steady flow from the beginning of the information system until the end of it's easy and simple. If you stop at some point and then try to get back on into the process, it's much harder. So keep it simple and maintain your system properly. The second pillar of sustainable software development is data, and getting this data under your control, and your controls more specifically. What we mean by that? One sustainable solution should only store the data that it actually needs, because every other piece of data is something that we have to acquire, we have to process it, we have to store it, and eventually we have to delete it. This all requires effort and requires resources and has impact on the system we are building. So keep the data limited to the ones that you actually need. For this, I must say that in Europe, GDPR has been a big help, because GDPR says that you cannot store data that you're actually not needing or you don't have permission to process. So this has reduced the amount of data European companies store tremendously. Also, what we get often is that I want to store this data because maybe at some day I need it. No, you don't. Or if you do, it's already outdated and it doesn't have that much point. In my 15-year career, I haven't really seen a case where this massive accumulation of data would actually make sense. Because if you get eventually to this data, it's already outdated. The second point regarding data is, one is storing it what you need, but the second one is storing it only as long as you need it. What we often see is that if we acquire some data, store it, and then it stays there. Because at some point, storing data was considered cheap and let it lie around there. You should not do that, because laying data still needs resources to store it, to back up it, and so on. It still has impact. And more data you store and keep, the amount of data grows very fast and very exponentially. If I said that we need to take our data under our control, what we mean by that? Information systems are not localized. They are not keeping the data where it is, where it's processed, and so that it would not go away or go anywhere. This is not the case. Information systems, one of the main functions is that they are processing data and sending and receiving it. They are integrating with other systems. When we imagine a system that sends out data, then, or we acquire something from somewhere, it is pretty often that developers say that, let's take everything we get, maybe we need it later. Or when we send something to somewhere, the developers say, let's send everything and they can figure out what they actually need. This is not a good practice because amount of data we send or receive has huge impact on planet as well. All the network hubs and processing on both sides of the both sides of the road still needs energy. Let's take a quick example of such case from people point of view. If you are a company and you want to send a newsletter to your clients, let's say you have 1 million users and you want to send them an email once a week. An average email last year was about 100 kilobytes. Million users, once per week, 100 kilobytes. Doesn't seem that much, but if we put it all together, it's 5 terabytes of data. 5 terabytes of data that we send out from our system to somebody else's system, where it gets duplicated, it gets backed up. If you are using some free email provider, then most probably they say to you that don't delete this email, we need it to get better picture of you. So, and some users also send it forward. So the data gets duplicated in external server, backup, some AI technology that analyzes this email data, and also your personal devices like mobile phones and your laptop. This is huge data duplication for cases where we usually or often don't need it. So we should only send the emails that we actually need, and don't send emails just to send an email, because you should really consider if you actually need it, because every piece of data that we send out is not controllable by us anymore. We cannot delete it when we think that this is it. This is end of this data's life cycle. I want to delete it now. If we have sent it out from our system, we cannot delete it anymore. It's out of our control. And email is just one example of such integrations. But one key factor of software solutions is that they are integrating with each other. Software is communicating to other software, integrating, using APIs or some other way of communicating. And the same practice should be applied there as well, that you don't send all the information you have if the other party don't need it. You send only the information that they actually need for a specific use case. For example, if one system is communicating with other via API, then good practice is to design your API in a way that one single endpoint serves only one purpose, so that you control that the data set you send out and receive is minimal, so that you don't send too much data and you don't receive too much data. The next point or practice about data is really the simple one. Bigger is not always better. If we talk about this point, then we mostly mean some media or some illustration video, some kind of data that is in such form, but also for other cases. But what we mean by that big size doesn't matter. For example, you should always consider the need in your solution for the size of the media that you're using. Let's take example of streaming. If your stream that you are doing, like we are doing at the moment, does not require 4K video, then don't do it. because 4K video uses vastly more data and resources than, let's say, full HD that we are using today. But size of media can be in other formats as well. It's not only streaming or video playing in somewhere or music. It's also about inner systems that actually make business cases. Because like video is not, if you talk about some business process, then video is not so mandatory usually. But if we talk about images, then these are often used. Either the customer has to upload something somewhere, some self-service, or we take some pictures during the business processes. We should always consider how we limit this use case and how much we limit the size of the data we are using. Let's say images that come from cameras, let's say from parking, if you go somewhere, park, and then there's cameras picturing your car to understand that it's you. Often these systems need to evidence that you were actually there. They have to store information about your car, a picture. But if we take this picture, it can be very different thing. Consider a picture that has everything on it. The background, the car itself, the license plate. It's very good resolution picture with high, all the colors, etc. The size of such image can be huge, like 10 megabytes, even more. But on the other hand, what do we actually need from this business case? We need evidence of a car from a license plate, that this license plate was pictured at that point, at that time. We don't need the background, we can cut that one. Make picture much smaller. Maybe we don't even need the car, maybe we just need license plate, even smaller. We certainly don't need this image to be high resolution. We can make it smaller. And what we probably don't need is the colors in that case. We can make it black and white. And with such simple steps, we can reduce this image size from 10 megabytes or 20 megabytes to a couple of 100 kilobytes maybe, if not less. That's a very big difference in amount of data you are actually storing. And now, if we are considering that these cameras, let's say there's 4 for each passage, and these cameras produce each like 10 frames per second, this is a huge amount of data. So limit the size of media that you actually need and nothing more. So let's move on to the third and last pillar of sustainable software development. It's where and how to run your system. Let's take the how part first. You can run your system in very different ways. You can basically run your software in your laptop or computer under your table, or in some data center in virtual machine that is reserved for you and dedicated for you. You can run it in cloud environment in virtual machine way, or you can run it in cloud environment in cloud native way. The amount of resources running system in these different versions needs on it, it will scale to 0. You have no cost, you have no impact on the planet. On the other hand, if your need grows, the cloud solution scales and you serve all your customers without any issues, and you only pay for the resources you actually used, and the impact is coming from the resources you are actually using. And what's the strength of cloud environments and cloud native solutions is that all these resources are not dedicated to you, but can be used by other parties as well, which means that the data centers we build have to be much smaller because the resources are different and business processes are different, which means that the peak hours where the resources are actually needed for different companies are different, and they can use the same data center to run their business on different times. The second case is about data centers. And if you cannot use cloud native solutions or you cannot use cloud at all, but you can use data centers, then you should carefully select which data center you are using. A couple of years ago, the PUE, power usage efficiency of a data center in the world, in average, was 1.55. This is pretty good, coming from 10 years back when it was 2.77 or something like that. But today, if you start choosing your data center, what you should consider? You should consider that this data center is high quality, it has low PUE. Today you should aim at least 1.4, better 1.2. Cloud and Amazon AWS say that they are using the PUE of their data center is 1.1. There's a huge difference in how they are managing their resources. So select wisely on where you run your system to lower the impact your system has on the planet. And the third point regarding where and how to run your software is about edge computing. Edge computing sounds a bit technical, but in reality, it's running software not in some data center or in cloud, but where the process is actually happening. If your system creates and processes a lot of data at some certain point, and you don't need to send everything to some data center or cloud or some other integrator, then you can process this data on site, on that position or place where this data is generated. For example, the same camera feed example that we had, where we have 4 cameras that all shoot 10 frames per second. And if car drives by these cameras, it takes about 100 frames for each passing. If you take these high resolution, huge images, 100 of them, and send them to cloud environment, for example, this takes a lot of resources from both network and cloud and the component on the site. But what you actually need to make your business work, you need some example of the car on that location. What you can do that you take these 100 frames, process them on site, see that from these 100 frames, this one is the best one. I will pick that one, make it smaller from 20 megabytes to 200 kilobytes, and then I send this information to cloud for further processing. This is huge impact on the network, on the cloud environment, and the component on site. If we talk about 3 pillars of software development, then it's pretty obvious already that these are not achievable by developers themselves. Sustainable software development is group effort. Of course, the developer is in the middle of it, but every single role in the company pitches in from their perspective. Is it the business leader who says what's the goal for the company, or the team leader, or the analyst who says that we have to achieve this goal, we can do or use these business processes, or it's the architect or the operations people on where we should run this. So developing sustainable software is group effort. It cannot be done just by developer. Developer can develop the software, but it cannot achieve maximum sustainability from software. But if there's one key point I want to make is that you should always aim to solve the right problem. Because it doesn't matter how well is your software built until it solves a problem that is not actually a problem, or it serves a business process. in a way that it's not actually required, then this is not optimal, this is not sustainable. Useless software is always a waste and is not sustainable. With that point, we are concluding our presentation today, and we have some additional materials here. We have Helme's blog, where you can find additional information on sustainable software. We have Green Software Foundation, who has published many different articles on green software. And also there's one link to one book written by Niklas Sundberg. It's Sustainable IT Playbook. This gives a good insight into how to develop sustainable software, especially from leader point of view. And now Meelis has joined me on the stage, and we can see what else makes difference, and then do we have any questions?
So let's take a few questions, and I see we have one incoming. So the question is, what practical first steps do you recommend? Where should we begin if we have already digitized quite a large amount of our business? So Kaspar, what do you think should be the first steps? Where to begin?
Sustainable software is not something you can make overnight, and you should not do it. If you have already digitized solution in place that your company is using on a daily basis, the first step, you need to understand where the impact from this system comes from and how it's run actually. And if to get this picture, it's always to cooperate with some partner who actually knows the topic, and can you help pinpoint these points that you can improve on. So this is the first things I will take.
So some thoughts from me as well. It's you can't manage what you don't measure. So before going and self-diagnosing and start making everything green, it kind of makes sense to measure. Is there an actual problem? How large is it? Is it today's problem, or will it happen when you scale your organization to 10 different countries and you will become successful? So also kind of evaluating which kind of interference, implementing some changes is actually necessary. There is no point jumping in and over-optimizing something that doesn't scale or doesn't grow. Okay, we have also time to take, I think, one more question. So the question is, can you provide some tangible examples of how green software is more cost-effective? I think Kaspar already gave a few, but maybe to elaborate on some else.
The thing is that, like we have said today, that efficient software is sustainable, and this is correlates with cost quite well. If we talk about development, green software or sustainable software, then development part is not that different from the regular one. But where the cost effectiveness comes from, and where we can actually see in our daily work, is that if your system is well built and in an efficient way built, it requires less resources. And if you run in your software in environment that is scalable and in an efficient way, then the cost effect is dramatical. You can see how much less resources it needs to run this software, and then the cost, thanks to that, goes down as well. So if you choose sustainable software or green software and run it in a sensible way, you see huge difference in cost. We can, in our systems that we build on daily basis, we see huge drops on cost for same piece of functionality. And on some cases, if we bring some real-life examples to our customers, then they ask how it's even possible, because using, for example, cloud-native solutions in effective way and knowing what you are doing, it reduces the cost dramatically.
And I kind of agree. It's just look at your cloud bill, look at your hardware electricity bill, and the bigger it is, probably the more opportunity to make something more efficient if you understand what needs to be more optimized. And I also know, talking about numbers, if Kasper, from one example, if you can reduce like up to 1,000 times of your storage needs, then we are talking maybe on a year like hundreds of thousands of euros, or depending on the size of the business, and then up to 100 times energy kind of reducement on some components. So depends where you live as well. In some places the electricity is cheap, but it's dirty, so it has actually more harm on the environment. In some places the energy is very clean, and all you have to kind of recognize is to understand, can we, how long can we work with the existing hardware without needing to upgrade it? All right, so I think the time is up. I don't know if we can take one more question. Let's see. Yep, so the time is up. Thank you everybody for joining in, and I really appreciate that we are all on this planet together. So working together on these issues, spreading the word, spreading the actual practices that you and me and Kasper, everybody can do in our position, on our role. You don't have to be a coder to make a difference. This starts from every stakeholder in this kind of building the organization and building these systems. Thank you.
Thank you.